First of all, I would like to start by welcoming you to a new edition of what we like to call the discussion on business, science and culture, today in the direction of science. For those I have not personally met, I'm Karl Matthias Klause, head of the economic department of the German embassy in Washington, and it's a real pleasure for me to welcome you all. One of the finest remits in my department and in German-US cooperation in general actually is the field of science and research. So thank you for all listeners or viewers. You've made a great choice today to join us. Our host today is the German Center for Research and Innovation in New York. That's actually a great institution in the US with the task of getting German and in particular US researchers together. So thank you for hosting that, because they really know what they are doing. And of course, a special thank to Bastian Hermisson. He's the director of the Heinrich Böll Foundation in Washington, with great expertise in the subject today. And of course, now my main thanks goes to our guest today, Dr. Friederike Otto. I've seen that the title, and you've seen the picture of her on the title, but angry weather doesn't go very well together with a smiling face. But anyway, so now you can see it's angry weather, but it's a smiling face. So thank you very much. I mean, she's a great expert in the field, and I'm glad we come together to have what I believe a very interesting conversation on climate, weather and the scientific difference between them. In a time of wide-ranging wish of reducing climate change, possibly reconstructing parts of our economic system, which is mainly called a capitalist system in the US. In Germany, we call it mostly social market economy. And of course, whatever the form is called, it should be greener. That's the idea. And to do that in a proper way, we need a good scientific foundation. And Dr. Otto is leading in her field, and the research she does is absolutely important for all the decisions that we will have to take in future. And that's why it's thank you again that you would come. And I leave it now to Bastian Hermisson to introduce her and then move on with the whole event. So thank you very much again for joining us, and please enjoy and participate in the discussion.
Thank you, Mr. Klause, so much. I think the next to speak is me. So dear Dr. Otto, dear Mr. Hermisson, dear ladies and gentlemen, my name is Benedikt Brisch. I'm the director of the German Center for Research and Innovation, what Mr. Klause just mentioned, here in New York. And it's my pleasure and honor to welcome you here on behalf of our center. And I'd like to thank the German Embassy in Washington, D.C., and of course the Heinrich Böll Foundation for their support and partnership to organize today's web talk as part of a series. And in particular, of course, I also thank Dr. Otto for joining today's talk with her presentation on angry weather. Let me say about this, I like this title, Angry Weather, very much. And Mr. Klause referred to the nice picture that is presented to the audience. Well, I hear angry weather, I can hear people being critical about it, maybe saying nature doesn't have emotions, nature cannot be angry. Now, that may be true, however, it's not how humans usually, I think, experience nature. Throughout mankind, people were dependent in their existence on nature. Nature could give them a life of joy and riches, and it could also take everything away in an instant. Industrialization, science, technology have made us more independent from nature, which sometimes makes us forget how dependent we still are. Our lifestyle has impact on nature. We know from science we cause climate change, and we may experience weather as part of nature as being angry more often, even if we know it is not an emotion, but a consequence by the laws of nature. But research and innovations, and this is the task of our center, are essential to help us to work our way out of this climate crisis and find a path to a prosperous and healthy life on a global scale. With this brief reflection, I look very much forward to Dr. Otto's presentation today, and I'm sure our audience does too. And let me briefly just mention, for those of you who are here for the first time, Mr. Klause mentioned the German Center for Research and Innovation. I would also briefly mention it's established on the initiative of the German Federal Foreign Office, which is currently promoting 5 such centers around the world in Sao Paulo, New Delhi, Moscow, Tokyo, and here in New York. So you might consider subscribing to our newsletter on our website so you'll be informed about all of our further events. I hope you enjoyed today's web talk and that you also consider to participate in the following events of this series. So stick around. And with this, let me hand over to my colleague, Katrin Di Paola, the program coordinator of the DWIH. Thank you.
Good afternoon, everybody. I'm also very, very happy to be here with you. Thank you for inviting us into your homes, into your offices and everywhere else. It's a pleasure being with you. And I'm trying to also prevent people from getting angry or having the emotion getting sparked to be angry by making sure that the tech is working today. So allow me for about a minute to familiarize everybody with the tech features here. We're using WebEx. You might jump from platform to platform and all of them are slightly different. So to get the best experience today with us, I just want to focus you a little bit to the upper left hand of your screen, for example. And the first thing I want you to do is click on the icon or the wording that says view. If you click on there, you can see themes, and there you can actually darken the background of what you see, and that's much more agreeable to the eye, I find at least, than the light gray. That's the standard setting. In addition, of course, you're all familiar with what we see at the bottom. You have the mute button. Please be on mute while the presentation interview takes place. And then later on, when you have a question, make sure that you unmute yourself and ask the question. And also feel free, of course, to turn on the video. It's always nice to see anyone or to see you when you're asking a question. One feature that we like very much for these events is the little one where you can see the smiley icon. If you click on that, not only do you see where you have to click to raise your hand when you have a question, you also see reaction emojis. This is a very helpful feature for all the speakers that we have because you're not sitting in front of them. There is no actual physical chemistry going on, but by giving, clapping, I see clapping here and I see you can celebrate. It helps a little bit more when you try to engage in a virtual space. So please make use of that as you see fit. The last thing I want to show you is on the upper right-hand corner. That's the button for layout. Here you can switch to full focus or to grid view, whatever you prefer if you want to focus on just the speaker or see everybody who's here. Of course, feel free also when we have the question and answer session to use the chat function at the lower right bottom. If you don't want to be seen or if you don't want to speak in front of everybody, or if you just have a question while the talk is going on, and then we moderate and make sure that we answer everything. With that, we can finally begin, and I'm going to hand over to Bastian.
Thank you very much, Katrin, and also a hearty welcome to all of you. I'm very happy to have the honor to hopefully guide us all well over the next 51 minutes of this exciting discussion today. So welcome to this installment of the climate edition of this event series. The climate crisis, is a core topic of these days. If you check out any news, and it is so because it is a defining reality of these times. Last week on Earth Day, we witnessed an international climate summit hosted by President Biden, where 40 global leaders met to discuss the state of climate change, and importantly, most of them provided national pledges and commitments to reduce emissions and preserve the environment. The run-up to the next global climate conference in Glasgow later this year. This conference will be crucial because it sets the course for the coming decades, the 30, to either set the global economy on a zero-carbon track or not. Since we're so many German institutions here, I also want to point out that yesterday was a historic day in Germany. Constitutional Court there sided with plaintiffs in a hallmark climate case brought forth by young people around the group Fridays for Future. And the court decided that the current German climate policy is insufficient from a constitutional point of view because it risks severely limiting basic freedoms of people in the future. So much is happening these days in the policy world and debate. This is, of course, also because the effects of the climate crisis are becoming ever more noticeable to all of us by the day. That is what we're here to talk about today, and where I'm really glad that we get to speak with Dr. Friederike Otto, We are truly fortunate to hear from her as one of the most relevant and exciting climate researchers of our time. Dr. Otto is the Associate Director of the Environmental Change Institute at Oxford University and has dealt with one of the most vexing issues of climate science, namely researching the relationship of extreme weather events with climate change. Here in the United States, a country that has a long history of extreme weather events, this question has become a core one in the political debate on climate change. I remember myself those debates when Hurricane Katrina hit way back in 2005 in New Orleans, when we also started to get a debate in the United States over the nexus of climate change and social justice and how climate change tends to affect the most vulnerable the most. The last years we've had this debate here in the US with other hurricanes, such as the record season last year, with record wildfires out west, with the cold spells engulfing parts of the country where it is rather unheard of, like in Texas this winter, or with floodings of historic proportions. And what Dr. Otto has done is truly groundbreaking research into those events, taking into account a wide historical and geographic perspective. She has become a core researcher in the new field of climate change attribution. Her book, called Angry Weather, has become a bestseller. I highly recommend it to all of you because it is not only one of the best books on the current climate science, but also very accessible to the layperson like myself. Dr. Otto is also one of the core contributors to the IPCC, the Scientific Council of the United Nations regarding climate change. So again, I'm very glad that we get to hear from you about your research, Dr. Otto, and without further ado, the screen is yours.
Thank you very much. That was, wow, that was an introduction. So I hope I can keep up with that. Yeah, I'll just give a very brief 10-minute overview of the science. Of course, there are a lot of other aspects that I will not talk about that that we hopefully can get into in the questions. But I would like to start with what actually you have just said, that whenever there is an extreme weather event these days, the question immediately arises, well, of course, this is angry weather, but is this climate change or not? And for a very long time, there were mainly two answers that scientists or basically everyone who has been asked the question has given. And the one was that's not possible to attribute individual weather events to climate change. Or the other answer that is given is, well, we are living in a world where climate change is happening. So of course, climate change is playing a role. And the latter is trivially true, but it doesn't actually tell you much because it doesn't tell you what this role is, whether it makes the event more likely or less likely or has no actual discernible effect. And so the first answer that was usually given is now not anymore true. And that is thanks to the science that we have developed, which is called extreme event attribution or weather and climate attribution. And now I need to find my controls. Here we go. The question is usually phrased, was this climate change or not? And there is no answer to that question that is yes or no, because every extreme weather event and every weather event, extreme or not, has always multiple causes. There's always just the chaotic variability of the weather system that is playing a role. There are other drivers, like whether the weather system is happening over a city or over a forest or a desert that has huge influence on how the exact weather system will develop. But external drivers like man-made climate change can influence the likelihood and the frequency of an extreme weather event to occur. And there are basically two ways of how that happens. The first one is what we would call the thermodynamic effect, or the effect from the warming alone. So we have more greenhouse gases in the atmosphere. That means the atmosphere as a whole gets warmer. So on a global average, we see more heat waves, fewer cold waves, and also a warmer atmosphere can hold more water vapor that needs to get out of the atmosphere. So again, on a global average, there's more extreme rainfall. But then there is a second effect, and that is what I would call the dynamic effect, which is that because we have changed the concentration of greenhouse gases in the atmosphere, and so how the atmosphere is made up, we have that influences the atmospheric circulation. So that is where weather systems develop, how they develop, and how they move. And these two effects always work together, and they can either work in the same direction. So because of the warming, you get more rainfall, and you also get more low pressure systems that bring in rain. So you get even more extreme rainfall in a particular place in a particular season. But they could also work against each other. So you can have, on a global average, as much extreme rainfall as you like. If you don't get the weather systems that actually bring in the moisture into your region, there will be no more rainfall in your region. And it can be that these two effects cancel each other and there are no changes, or it can be that, if you like, the dynamics win. And so you actually have fewer extreme rainfall events or less intense. And because the second effect is very different from region to region and from season to season, it affects different types of weather very different, you have to actually look at individual regions and individual weather events to answer the question what the role of climate change is. And so what you can see on this slide is the main idea of how we do that. So we want to know whether, let's say, Hurricane Harvey whether climate change has affected or has played a role in Hurricane Harvey. So the first thing is we need to define what actually is Hurricane Harvey in terms of a variable that you can simulate with climate models and that you can measure. And so one of the most destroying things about Harvey was the huge amounts of rainfall it brought. So we could say that the extreme event that we are actually interested in is rainfall above 1,000 milliliters in the 3 days that Harvey hang around Houston. And so we define that as our event, as our extreme event that we're interested in. Then we need to know not only what the actual event is, which is what we have observed, but what is possible rainfall in the hurricane season in Houston, in the world we live in today. Because in the observed record, we have all the actual weather that has happened, but not the possible weather events in our given climate. And so to find out what is possible weather in the world we live in, we use observations and statistical modeling, and we use different climate models and model, okay, what is possible rainfall in Houston in the hurricane season in the world we live in today. And then we get a distribution of possible weather, and we might find out that in the world we live in today, Harvey rainfall amounts are still a very rare event. Let's say it's a 1 in 300 year event. And then we know what kind of event it is that we are dealing with today in a world with climate change. We have already 1.5 degrees of global warming. Then we need to know what is possible weather in the world that might have been without climate change. And we can do that because we know exactly how many greenhouse gases have been emitted since the beginning of the Industrial Revolution. And we can take these out of the atmospheres of climate models and use these to then simulate what is possible weather in a world that would have been exactly as our world today, but without the greenhouse gases. And then in this totally exaggerated schematic that you see here on the slide, you might then get a very different distribution, and you find out that your extreme event was even less likely in the world that might have been without climate change. So let's say it was a 1 in 900 year event without man-made climate change. And because the only difference between these two worlds are the additional greenhouse gases in the atmosphere, you can then attribute this change to climate change. And you can say that because of climate change, Harvey has been made 3 times more likely. So that is the whole idea behind attribution, behind event attribution, which is in principle really straightforward. And doing it in practice is often not straightforward. But some of the results we get are, for example, a heat wave that has happened last summer in the whole of Siberia, and in particular with extremely high temperatures in Verkhoyansk, a city close to the Arctic circle. And we found that this event would have been almost impossible in a world without climate change. So the likelihood of that event to occur was so small in the world without climate change that climate change really was an absolute game changer there. But not all events are being made more likely because of climate change. So another example of an event that we have looked at with my team is a drought in Sao Paulo that had led to huge impacts in 2014, 2015 in the large area around Sao Paulo, with water shortages and huge problems that, again, particularly the vulnerable parts of the population had to pay for. And that event was about a 1 in 10 year event in the world we live in today, but it was also about a 1 in 10 year event in the world that might have been without climate change. So climate change really did not play a big role here. And we actually also found in the historic record that similar kind of droughts happened in the early 2000s and in the 1970s. And then we asked, okay, but why were the impacts so strong this time, which they weren't in the historic events, and found that, well, in the 10 years between the last drought and this one, the population in the area had increased massively, but particularly the water usage had increased exponentially in that short time period. And so that was actually what led to the huge damages, and it was an event which was not due to climate change. So these are just two examples of two events that we have looked at, and Harvey is a third one. So a priori, because you always have these two different effects, the warming effect and the dynamic effect, you have a priori 4 possible outcomes of each attribution study. It can be that the event was made more likely. It can be that the event has been made less likely. It can be that both effects cancel each other out and there's actually no change. Or it can be that with our current understanding and our current tools and data, we can't actually do a study. And so we now have the tools to find out what are actually the effects of climate change today. And this is a map that has been put together by Carbon Brief, which is a climate and energy news outlet here in the UK. Of all the studies, all the attribution studies that have been published. And you see the red ones are where climate change did play a role, the blue ones are where climate change did not play a role, and the gray ones are where we don't know. This is, though, not representative at all. This is a map of all the studies that have been made, but not of all the extreme events that have happened. And so there is, on the one hand, a huge bias into where scientists live, because we like to study the events in our backyard, and scientists are there are many more scientists in Europe and North America and Australia. And also it is biased towards events that are well represented with present day climate models, so heat waves, large scale rainfall events, where also climate change does play a big role. Other events like hailstorms, which we would love to know what the role of climate change is, but we don't have the tools at the moment to do that. And then, of course, it is very difficult to publish a study where the conclusion is, well, we can't say, because we don't have the tools, or we don't understand what's going on. So all these non-results very rarely see the light of day. And so to finish, I tried to put to find out how big is actually the discrepancy between what we know about the effect of climate change on extreme weather, so where attribution studies have been done, and the extreme events that have actually happened. And on this map, I have used death associated with extreme weather as one measure of extreme events, that bad extreme events. And you can see in the red circles are the number of deaths associated with extreme events since 2003, which was when the first attribution study has been done. And they are all placed on the capitals of the countries, and the larger the circle, the more death because of extreme events. And on top of the red circles, I have plotted black circles, which show the death associated with extreme events for which we know what the role of climate change is. And you can see that, for example, if you look at Moscow, there's a large red circle, which was mainly a big heat wave in 2010 and another one in 2012. But on top of that is a big black circle, because we have studied these events. We know what the role of climate change was there. But when you look at another big circle in north of India, which is Myanmar, there was basically two big tropical cyclones with huge death tolls, and we have not studied them. So there is really it's really unclear what the role of climate change is. And so, yeah, I'll leave it at this. We have now the tools to understand much better what present day impacts of climate change are. And of course, you can use the same methods also to say, okay, and how different would this event look like in a warmer world, in a 2-degree world? But we are very far from having applied it to actually the events that have happened, and especially largely damaging events in the developing world.
Now I could unmute myself. Thank you. Dr. Otto, thank you very much. Few minutes to ask a couple follow-up questions, and then it's your turn, but you could already think about comments or questions at this point. And just so you know, feel free to put them in the chat. That's one option. You can do that now. Or at the bottom of the screen, again, you have a little smiley emoticon. If you click on that, you can go on raise hand, and then you would have a raised hand, and I could take you and you could ask your question yourself. So what I want to pick up on, Dr. Otto, is what you said towards the very end of your talk of how this research could potentially also be applied to forecasting, right? And to having an effect on policy going forward. Is that something you could say a bit more about, where you see the potentials for this to apply also to forecasting and making models for the future?
Yeah, so I think one potential really important application of this methodology could be towards adaptation, because most climate projections that are currently done and that are used to inform adaptation are on a relatively large scale, and also country or large regions, and also on just mean variables, so mean temperature changes, mean rainfall, average rainfall changes. But what actually really drives damages are, of course, extreme events. And so by doing these attribution studies on extreme events that are actually happening, we first of all understand much better what we are actually vulnerable to. So what kind of event is it actually that really drives the damages in a particular region, in a particular location, and also, of course, that's different also for different sectors. And then we can use that to say, how have these hazards, how have they changed, and how are they changing in a warmer world? So what's the role of climate change going forward? Is what we've just experienced, is that a harbinger of what's to come, or was that really a very rare event?
Thank you. That makes sense. Now, if this could lead to a more informed discussion on adaptation measures, then basically going forward, do you see a risk that politics and society will take this research and focus mostly on adaptation, on how we can protect ourselves from these future extreme events and things like that, and detract from the effort on mitigation, so on reducing emissions at this point?
I don't see any danger of that, because still we have almost all of the debate that we have on climate change is about mitigation. And of course, mitigation is important. We need to stop burning fossil fuels. Otherwise, the problems will get a lot worse. But we already have 1.2 degrees of global warming right now. And already people are dying because of climate change. So we are not even adapted to today's climate. So I think we need to have a much more of a discussion and debate about adaptation, and also the way adaptation is dealt with in, say, in the UNFCCC, so in the United Nations climate discussions. We have an inventory of emissions. We have a task force of metrics for emissions, so that what each country is doing is compared to a standardized, comprehensive way of things. So in the to standardized, comprehensive measures, and so it's very clear if countries are doing what they said they want to do for mitigation. But we have nothing like that for adaptation. So we don't have an inventory of what the impacts of climate change today are. We don't have agreed upon metrics of what you actually compare your national goals and adaptation against. So how is that measured? And so it's and I think there is really no danger that we adapt too much and focus too much on adaptation. I think we need to focus a lot more on adaptation.
Thank you. A follow-up to that adaptation discussion. Here in the United States, there are now massive coastal protection projects in the Gulf of Mexico, for example. New York is planning projects for billions of dollars to protect itself from rising sea levels. So there are, steps that are being taken in Miami and elsewhere, some of the really affected regions. But what about the regions and countries not able to do so? So what role do you see for climate finance, for development aid, and for those that have caused climate change the least and that are suffering the most?
Yeah, well, I think actually the most interesting thing that Biden has said in the Earth Day climate conference was that the US is going to triple their budget on developmental aid, because we will not solve the climate crisis without serious investment in climate finance in also not just the developed world but the developing world, to finance adaptation, but also and I think crucially not just building projects and dams and which is currently where a lot of developmental aid is going to, but financing changes in social structure, social systems to enable adaptation to come from the countries that are affected and that are most vulnerable to climate change. So I think, that was something that was actually not talked much about in these climate talks. It was sort of a side note, but I think that is one of the most important things that that the developed world primarily needs to do to get a lot more serious about climate finance.
Thank you. This global inventory that you are suggesting, right, to someone like me, that makes perfect sense. And I wonder why, is there a lot happening in this direction? Or if there's not enough happening in this direction, what is the holdup? What are the challenges that you see to make this a reality and to put the field that you're working in into a stronger position, I guess, in the global discourse on how to adapt to climate change?
That's a good question, and I think a big reason of why this is not happening or hasn't happened so far is because, well, if we try and make an inventory of the impacts of climate change today, it will not be comprehensive. There will be gaps because there are parts of the world for which we don't have data to actually know what is happening right now, and how. We have no observations to compare our climate models with to evaluate them. So our tools are quite limited in some parts of the world, and also for some types of extreme events. So for example, hailstorms, I've said climate models cannot simulate hailstorms. And so I think there was a bit the better was the enemy of the good. So that because it will necessarily have gaps, there was, okay, we can't do this because it will not be comprehensive. I think that thinking is slowly changing, that it will still be useful to start. And because, of course, by doing this, you will develop better methods. You will actually see how useful collecting certain types of data is. And so it will help data collection, I think. But it's a lot more difficult to do that. And you need a lot more different data sets and different types of models than you do build an inventory of emissions. So I think the task is just bigger, and so that is, I think, the main reason for it not having been done so far. And then also that you actually have tools good enough to really do climate projections at the scales where adaptation decisions are being made, at the scales of counties and cities, is only relatively recent. So I think there is just inertia for the scientific development to filter through into politics. But I still think that we also just need to talk about it a lot more to make it clear that this is something that is now doable and really needed. Because I don't think you can do, even if you in some cases will not have the evidence to do adaptation, you still need to build resilience and need to just then adapt to a broad spectrum of weather. But I still think that where you have the evidence, you should use it, and it makes it, it also puts it just on more equal footing politically.
Thank you very much. And just one more question from my side, and then again, everyone, please get ready. I see one hand up already and one question in the chat, which is that when I looked at that last slide of yours, right, of deaths in countries that you can attribute to climate change, and when I then think about the fact that this is only looking at the surface, right? Because there's so much we don't know and so much information we don't have. That looks so dramatic that I want to ask you to what extent you think, when you translate that into a political discussion, that it could also quickly go from inaction or not adequate action to calling for very drastic adaptation steps, such as geoengineering. So artificially influencing the physical processes in our atmosphere or of some ecosystems at large scale. And if you think that is inevitable, that we talk about those kind of steps or problematic. Thank you.
I think there will definitely be discussions about geoengineering, but I think particularly for adaptation, it will, the geoengineering solutions that we know work. So we know that if you put sulfate particulates into the atmosphere, that blocks some of the incoming sunlight, so it will cool it will cool the Earth. But at the same time, those particulates in the atmosphere have a strong influence on rainfall. So they have a very strong influence on the monsoon, and so you would you would maybe help with some of the effects of heat waves, you would in the same time cause massive droughts because of the influence on the rainfall. And so and that is the only geoengineering that we know that works. And so people still keep talking about it, but I think by having inadvertently done experiments like that just through air pollution in over the last years, in particular between the 50s and the 80s, we now know how much influence that had on rainfall, and so I think that is an experiment we shouldn't repeat, because it will just, yeah, there is no way that you can say, okay, heat is worse than drought, heat here is worse than drought there, and so we do it. So unless someone comes up with something that that does not have any of these side effects, and I don't know of any, and I don't think anyone does, I don't think that is a solution.
Take one question from the chat and then turn to Mr. Klause, who has his hand raised. So a very practical question on your book. The question was, where can I buy it? And was it originally in German or English? I can say it does exist both in German and English, so you can choose. Someone posted an Amazon link, but I also want to point out you can order it through your local bookseller as well. It does not have to be Amazon. Again, I highly recommend it. But was it written in German or in English originally?
That's a good question. It was first published in German, but actually most of the material it's based on was written in English, because that's the language I work in and I publish in. So I've translated it first from English to German and then back to English.
Thank you. And with that, Mr. Klause, please, the stage is yours.
Thank you very much. That was very interesting and very exciting. And I'm also very impressed by the sort of cold, I don't want to use the wrong word, but neuter look that you use to look on all the events and how it's developing. There is one remark and then one question. It's really interesting that you mentioned yourself the sort of two-track approach of mitigation and adaptation, and the question why it is actually not that. I mean, I'm not sure whether I'm 100% in all the debates, but to be quite honest, I have the impression that I hadn't heard this adaptation theme as much as other themes, and maybe it's also a question of political courage, because if you talk about adaptation, you basically accept climate change happening, and maybe as a politician or in debates, people don't want to do that. But anyway, I think it's very interesting. I think it should be actually more in the debate to go both tracks, mitigation and adaptation, and find measures and financing and everything that has been mentioned to counter that. But my question is more scientific. I mean, it's not scientific, it refers to science. Obviously, you are using your model and you are probably convinced of the maths or whatever you do there. Is there any prospect of a sort of global standards for different kind of research that can all be then sort of used on the same level? Or you've mentioned some of the research done in different parts of the world. I mean, is that a common scientific understanding that basically the same models are used and it's trustworthy to be comparable, or how does that look on the?
That's a really good question. I'm totally not convinced about the math or the models, because all climate models are, well, as Jim Box says, all climate models are wrong, but some are useful. And so you have to find out which ones are useful for your problem, and so in that case, for the extreme event in question. And so we have, and some of the early attribution studies that we've done, I would not recommend using them, because it took us a while, I think, to develop methodologies that actually where you can assess the confidence you have in the results, and so that where you have a good a good estimate of is that result something that is robust or not. And we have now developed a best practice approach, and that actually uses basically use every model that you can get your hands on and put it through the same evaluation test to find out which ones are actually able to simulate the event that you're interested in. And it happens. So we wanted to do an attribution study of an extreme rainfall event in Madagascar. And we started off with about 20 different climate models, and we ended up with 0 because none of them were able to simulate that type of event. So that does happen, and I think it is necessary to do these steps and to develop some. Yeah, so there is a balance between using as many different methods as possible, because that you learn always something different and something new, but to still have your results comparable. And so I think one exciting development is that in Europe, and I think actually also in the US, there are thoughts from the Met services to operationalize event attribution, so that basically not scientists, but the meteorological services provide an assessment of the role of climate change following the methods that we have developed. And that really, and we are currently doing a pilot study in Europe, and that really forces you to make your methods much more bulletproof and much more robust if you have to make it so that actually an operational service can do it repeatedly.
Thank you. There was one question from Patrick in the chat about carbon sequestration. So for those of you that don't know the term, geoengineering refers to large-scale man-made changes in the atmosphere or in larger ecosystems, whereas carbon sequestration, sometimes called CCS, carbon capture and storage, is about taking CO2 out of the atmosphere and sequestering it and either burying it underground or in some other way, hoping that one can capture it the same way that trees would do, but technically. So do you think, and for Joe Biden, for example, CCS technology is an element in his own climate plans, as in many other governments. And do you think, Dr. Otto, that carbon sequestration is key if you look at where we already are today and where we're moving in the next decades?
Well, I would at least say that given the speed of mitigation, it will be very difficult to see how we could reach the 2-degree goal or the 1.5 goal without sequestering carbon. And so I think it's definitely, it would definitely be a very good idea to put some serious research behind CCS, because at the recently there have been some test plants that do that, but most of them have actually been closed again because climate goals in countries were so, or at least the legislation that came with the goals were so that it was not viable. And so I think we know that carbon sequestration works, but at the moment it's still extremely inefficient. And so I think research is really needed on that. And so, yeah, I wouldn't, I think I want to make your goals or your climate goals, and especially the legislation, so that you don't rely on it too much, because as I said, as far as we know, it's very expensive and very inefficient, but I think it might be necessary.
Thank you. There's no other questions in the chat right now. I will take the liberty and ask another one myself. And maybe it sounds a bit far-fetched, but I've just been wondering about it. Climate science was one of those areas of science that for a long time has worked on a truly global scale, where there has been global cooperation, really in an exemplary fashion, I think. And now in the last 1.5 years, the pandemic has brought us to a situation where there has also been this massive push for global cooperation for, an existential issue. And do you find that there have been lessons learned both ways? That have you heard anything about, for example, COVID researchers looking at how climate scientists have cooperated globally? or the other way around, that you can now learn from each other of how we can think about pandemic preparedness as a big vulnerability globally and climate change preparedness as well?
Well, I definitely know of some scientists from other fields who are very jealous of the climate science, because it's very easy, actually, thanks to the IPCC and this very systematic global collaboration that we have as a community have. It's very easy to find out what is the latest research on heat waves, what's the latest research on CCS, because we have this big IPCC reports in which every 7 years the community comes together, reads all the literature that has been published on the topics in the last 7 years, and then makes an assessment. Okay, what can we say on which topic? And that is no other scientific discipline has that. There are usually more different tribes doing one thing in a certain way and the other way, and it's much harder to get this overview. So I know that also. So some of the colleagues here in Oxford who have developed the vaccine are in my college. So they have said it would have been so much easier if we had that that kind of enforced collaboration, which I think does the science very good. I think the other way around, what the pandemic has definitely shown us is that we can't look at climate in isolation. We have to look at complex and risks of climate and other environmental and other risks together, and see, okay, how can we do our risk assessment to really do these overlapping risks justice. I'm not sure we have an answer yet.
Thank you. I have a hand raised from Mechthild Schmidt-Feist. And
yes, hello. Can you hear me? Okay, so my question is actually something that I had passed along before. We're talking so much about technological development that is still in a research phase, and to even scale it up, and we don't even know if it's going to work, is going to take so long. So my question is, do you think of sequestration, mitigation, or adaptation as a viable strategy, or just a last resort when really, we don't have to wait for studies to know that we have to change our economic model of growth and consumption and have to find more sustainable ways and not put the CO2 into the atmosphere in the first place? So if we actually wait for technology to possibly be able to catch up with us, it may be too late. And this also refers to the decision in the German courts yesterday that actually holds the German lawmakers responsible for the well-being of the next generation, which I think is it's an amazing decision, and hopefully that's going to get used as a case for other countries as well, where similar lawsuits are on there. So basically the question is a technological fix actually a viable strategy?
Absolutely not. So we have to stop burning fossil fuels, and we have to stop burning fossil fuels, well, ideally yesterday, but as soon as possible. So CCS, because the way how the political system seems to work might help with some of the remaining emissions that are very, very hard to decarbonize. But we do know how to decarbonize transport apart from airplanes. We do know how to decarbonize heating. We have to do it, and we have to. And I totally agree that the decision yesterday from the court might help, that actually there will be the legislation that is necessary to for houses not to be built using fossil fuels, and for cities to be designed not so that it actually allows us to change our economic system from not be dependent on fossil fuels. Yeah, I absolutely agree. We have to do that. There is no technology fix for that. We can't do that much CCS.
So should resources really be used for that still? Versus,
I think some of them should, because there will be remaining hard to decarbonize sectors, but it will never be at a scale that we can just burn coal as we're doing now, and not. So we have to do both.
Thank you.
Related question to that is on a specific technology that I had in the chat, which is direct air capture. That's basically, machines that filter air and try to suck CO2 out of this air and sequester it. So not at the power plants or something, but really directly out of the air. And the question was, do you think that is a technology, even if, as you just answered, technologies like this overall are not the fix to the crisis, but for the remaining emissions that we need to take care of? Could this be a promising technology or not?
I'm not an expert on direct air capture, so what I know of it is that is even way more expensive than carbon sequestration in power plants, and so it will not be something that can be done at scale in the time that we have available to decarbonize our economy.
Thank you. And with that, I would take the last two questions out of the chat and just read them to you. One is really going back to the attribution research that you are immediately involved in. And the question is, are some regions of the world easier to model than others, depending on what kind of climate they have? Is it easier or harder in tropical, subtropical, moderate climates? And the other question, I think, is a great parting question for this discussion, which is from Christian Bieler, and it's what kind of invention or action in the last months give you hope that we could turn the tide?
Okay, so at the moment it is it's not necessarily so that some regions of the world are easier or harder to model, but some types of weather are easier and harder to model. So rainfall on very small scales is difficult to model with state-of-the-art models, and that is more relevant in tropical regions than it is in, or it's only in summer relevant in non-tropical regions. Let's phrase it that way. And there's a huge I think the bigger problem is that climate models have traditionally been developed mainly in developed countries. So and there is not a single climate model, for example, that has been developed in Africa. And all climate models are built so that they are best for the kind of weather that is happening in the country where they are built, because they are usually built by the national Met Services, national climate centers, specifically with that country in mind. And so we have a big lack of just capacity, research capacity that has not been invested in large parts of the world. So I think that is the bigger problem than the different types of weather that we have. And well, I think the last what gives me hope in the last month was the question, right? So I think well, actually it has already been mentioned, but that the German Constitutional Court has said that that the current laws are not in line with the Constitution, and that there is a right for living in a decent climate in the future is something that is amazing. And I think that gives a lot of hope, because the German Constitutional Court is highly regarded in Germany, but also beyond Germany. And so I think it's really sending a very important signal that even if, if the governments are not doing what is necessary, then the rest of society has means and has actually power to do something about it. And I think that's a lot of reason for optimism.
Thank you so much. And I just want to say that there is so many court cases like this that young people around the world have brought forward. Here in the US as well, there is still a case pending that might one day be in front of the Supreme Court. If anyone is interested, there's a wonderful documentary called Youth versus Gov about this court case in the United States and these incredibly impressive young people that for years have been fighting on it. So the battle remains on. Again, this is a crucial year for climate research and climate action that in the end governments will have to take. Glasgow will be a really essential conference at the end of the year. And very glad, Dr. Otto, that you could inspire us with your research to think about it also as we continue the climate debate in the months ahead. So thank you again, Dr. Otto, so much for your insights, and all the best for your continued research and some of the political battles. And I want to thank the audience. I want to thank the German Embassy in Washington and the German Center for Research and Innovation in New York for organizing this event. And to mention it's part of a series. The next event will be an exciting one as well, with Katharina Reiche from Germany on hydrogen technology. So make sure to check that out. And last but not least, thank you to the excellent event and technical team behind the scenes that even managed to make this horrible microphone mishap not sound as bad. So thank you all. Have a great weekend and a good start into the May.
Thank you.
Thank you, everybody.